At the MD&M East and Atlantic Design and Manufacturing shows last week in New York City, exhibitors showcased a number of applications that exemplify the huge potential 3D printing holds for medtech. Formlabs, maker of the Form 1 desktop 3D printer, showed off an early iteration of the Sutrue wound closure device. This prototype was printed via stereolithography using an acrylic plastic similar to PMMA. The entire assembly process took just over 22 hours, and material cost added up to less than $12. Airwolf 3D, which makes desktop-fused deposition modeling systems for prototyping and direct digital manufacturing, had this cast made from standard ABS material and finished with an acetone vapor treatment. Because it was made from 3D scans of a person's arm, it's more ergonomic and holds the bone in the correct position better than traditional casts. It can also be cleaned easily with soap and water or even thrown in the dishwasher. Cimquest, a distributor of Stratasys 3D printers, presented an example of how 3D printing can be used for preoperative planning. This model of a conjoined twin skull was made with an ABS material on an FDM machine. The design was created from CT scan data, and the model was used by surgeons who performed the twin separation surgery. EOS, a provider of additive manufacturing solutions, exhibited this custom-made cranial implant. Made via direct metal laser sintering using the EOS INT M280 system and EOS Titanium 64 material, the implant protects against heat, is permeable for liquids, and features a lattice structure that supports the attachment and ingrowth of bone tissue. 3D printing is often used for prototyping and small-run manufacturing, but 3D Systems, a maker of 3D printers, proved the technology can also be used for volume manufacturing with these spinal implants. Made via direct metal printing using Titanium 64, the two implants on the left feature a porous zone that allows two adjacent vertebrae to grow together, a characteristic that must be added as a coating on traditionally manufactured orthopedic implants. Stratasys, a maker of 3D printers and production systems, had on hand this extreme prosthetic leg made for snowcross and motocross star Mike Schultz, who lost his leg in a racing accident. The device combined parts made on the Fortis 3D production system using Ultim 9085 with a Fox shock and has allowed Schultz to get back to activities such as snowmobile racing, horseback riding, skiing, cycling, and wakeboarding.